Today, we're not just talking about the next fancy language model, no. We are diving into the very first building block for a completely different kind of AI, one that's persistent, one that actually learns, and it all starts by giving it a memory it can truly use.
So, to really get this, you have to understand where the idea comes from. This isn't some new tech fad that just popped up. This is the result of a personal journey that started for its creator, Michael Tomlinson, way back in 1986, building some of the first simple neural nets. And his goal for 2026, an AI companion he calls Juliet, was inspired by watching the most powerful learning systems on the planet, his own kids.
And this quote, this really gets to the absolute heart of it. The goal isn't just a better tool or a smarter chatbot. It's to build something with a continuous existence, an agent that remembers, gets curious, and actually grows. I mean, it's like raising something alive.
Okay, so that's the dream, but there is a massive roadblock standing in the way. A fundamental flaw in every single AI we use today, from GPT to Claude. They all suffer from a really bad case of amnesia. Every time you start a new conversation, they start from scratch.
And this comparison just lays the problem out so clearly. On the one hand, you have us, humans. We consolidate knowledge. We build on what we learned yesterday. We have this mental scratch pad to focus on what's important right now. But today's AI, it just forgets. It hits the reset button every single time. And worse, it actually gets less effective the more context you try to cram into it.
So that's the big question, isn't it? How do we bridge that huge gap? How do you build that mental scratch pad for an AI and finally give it a real working memory? And that brings us to the blueprint for the solution, a module called DT-MEM. And the inside here is it's brilliant. It's not about making the AI's brain bigger. It's about adding a totally new component that acts just like our working memory. It's about giving the machine a whiteboard.
Seriously, this whiteboard analogy is the key to understanding the whole thing. Forget the complex math for a minute. Just picture a big whiteboard right next to the AI's core processor. And on that board, it can slap up to 1,290 digital sticky notes, each one holding a key piece of information it needs for what it's doing right now.
Now, technically, that whiteboard is called a memory matrix. It's a dedicated space with those 1,290 slots are sticky notes. Each slot holds what's called a 512-dimensional vector, which is just a really rich numerical way to describe a concept. And the incredible part is, the AI can read and write to this board in every single thought cycle.
So how does it actually use it? Well, it's this super fast four-step loop. First, it addresses the board, asking, okay, out of all these sticky notes, which ones matter for what I'm doing? Then it updates it. It decides, this note is old news, I'll erase it. This new info is critical, I'll write that down. And the system actually learns how to get better at this over time. Third, it retrieves the info, reading the most important notes to inform its next move. And then the cycle starts all over again. It's a constant, dynamic process of thinking.
The idea of a whiteboard for an AI is elegant, but the results are what make this a genuine breakthrough. I mean, the performance metrics are just stunning.
First, efficiency. An agent with this tiny memory module, weighing in at just 20 million parameters, performed just as well as a standard model with 200 million parameters. That's 10 times smaller. It's like getting the power of a server rack from a single chip.
And that efficiency means incredible speed and accessibility. It only took 50 GPU hours to train the DT-MEM model, compared to 1,600 hours for the big standard one. That's 32 times faster. This just opens the door for so many more people to do this kind of cutting-edge research.
But this chart is where we see the real magic. When faced with new tasks it had never seen before, the standard AI completely fell apart, scoring between 2 and 13%. But the agent with the DT-MEM whiteboard, it was able to generalize what it knew, achieving between 51 and 69%. It could adapt because it was reasoning with its scratchpad, not just pattern matching. So how does it learn so efficiently? Well, the key is you don't have to retrain the entire thing. To teach it a new skill, you freeze 99.3% of the model. You only need to update the tiny bit of wiring that connects to the memory, just 0.7% of the parameters. It's like surgical learning. And for all you developers watching this, here's the best part. This isn't some complex proprietary system locked away somewhere. The entire memory module is about 300 lines of standard PyTorch code with 0 external dependencies. You can literally copy-paste this working memory into your own projects right now.
Okay, so we have this powerful, efficient, and really practical working memory module. Let's bring this all back to the grand vision.
How does this simple component become the first piece of Juliet's mind?
This is where it all connects. That memory matrix becomes Juliet's short-term scratchpad. It holds the crucial context, her current goals, recent events, key facts. And crucially, this context isn't just text shoved into a prompt. It's injected directly into the AI's core thinking process, into its hidden states, like a high-bandwidth signal that shapes its every thought.
So you see, DTMem isn't just a clever trick. It is a foundational component. It's the first piece of Juliet's brain, a real notepad the AI can read from and write to at GPU speed. And that word differentiable is so important here. It means the AI can actually learn how to use its own memory more effectively over time. No hacks, no prompt engineering, just pure integrated memory.
So we've given our AI a notepad, right? The ability to remember what it's doing from moment to moment. But that just brings up an even deeper question. A notepad is pretty useless if you have no desire to write on it. If working memory is the hardware for thought, what provides the spark? What's going to make Juliet want to learn? What gives her curiosity? Well, that's the next piece of this incredible puzzle.